Hi everyone, how are you today? Hope you are doing fine. So you are welcome to today's lesson. We'll continue with our topic, our main topic, which is calculus. Now today our main focus will be on the stationary points, which are also called the turning point. So now, what is this point? So the definition of a stationary point or a turning point is simply that this is a point where the gradient of the curve is 0. So a stationary point, which is also called a turning point, this is simply a point where dy by dx is equals to 0. Okay, so now just giving a summary of it all, we have three types of turning points. So even when you are drawing the graphs, you are going to obtain three types of curves. So we have a curve which is called a maximum. So a maximum right here where the graph bends is where we find the maximum value, which is a y value. Okay, then also we have another type of a stationary point, which is a minimum. So at the bottom right here we have a minimum value. Then the third type is an inflection. So for an inflection, this is how it looks like. It can face in any direction, but it has a certain point where it is inflecting. Okay, so these are the three types of stationary points. Now, why are we learning about stationary points? We are going to see how questions in your exam can come. So for example, the simplest question of them can come: find the turning point for the equation y is equals to 3x squared plus 6x plus 1. So we want to find the turning point for this curve. Now this is an equation of the curve. So we want to find the turning point. Now by definition, we know that dy by dx is equals to 0. So a turning point is the point where dy by dx is equals to 0. So what you are going to do is step number 1, so solution number 1. So the first step that you are going to do here is you are going to differentiate the given equation. So you differentiate. That is the first thing that you are going to do. So differentiating, now we have our equation, which is y is equals to 3x squared plus 6x plus 1. So differentiating this one, we are going to say dy by dx is equals to 0, which is equals to this one comes down here times 3, it will be 6x plus 6, because a 1 comes there, it will still be 6x. We subtract 1 minus 1 is 0. Any number to the power 0 is 1. So 6 times 1 still gives us 6. Then the derivative of the constant number is 0, so we ignore it. So now we can solve this one because we have an equation 6x plus 6 is equals to 0. So meaning 6x is equals to negative 6 when it goes that side. So you divide by 6, you also divide by 6. You cancel that one, cancel that one, cancel that one. You have now x being equal to negative 1. So now you have found the value of x, okay? But the question is saying find the turning point for this graph. Now the turning point has to be a coordinate which should be in the form x comma y, okay? So now for such questions also, they actually specify. So this turning point, find the turning point for this one. So having found the value of x, the next thing you are going to do is you are now going to substitute into this one now, the same equation. So step number 2, step 2 here, you do a substitute. So substitution into the given equation. What are you substituting? The value of x which we have found. So you are going to say y is equals to 3x squared plus 6x plus 1. So this one here, it will be 3, open brackets there. You put your negative 1 squared plus 6, you put your negative 1 plus 1. So this one here, it is 3 because 1 squared, negative 1 squared is 1 times 3 is 3 plus. So this plus, now before you write plus, there is plus and negative giving us negative 6 plus 1. So 3 minus 6 is definitely negative 3 plus 1 here, our answer will actually be equal to negative 2. So having found this one, we are now going to say, okay, we can now find our turning point, or the stationary point, to be equal to, since the x is negative 1, so it will be negative 1 comma negative 2. and we have found our turning point. Okay, let's see now how best we can also see how it comes. So in paper one, mostly paper one of your exams, there is always such a question like this one, which doesn't miss in your exam. It always appears. So let's have a feel of how it can be applied in an exam situation. Okay, so using the same knowledge, an extract of the question we have been given here reads, find the coordinates. So the diagram below shows a sketch of the graph. There is a sketch of our graph. Okay, so for the sketch of our graph now, they are saying we should find the coordinates of E and G. So this is basic thinking. Look at how this graph is cutting the x-axis. So definitely here, this point here, the point that is here, that is the first thing. The point that is here, you can really tell that this is E, 0, because the y value here, right here, is 0. Then also here, you can also tell the same thing. This is G, 0. So the point is 0. So now, how do I find the E value here? Because E value is x and the G value is x. But in both scenarios here, as you can see, the value of y is 0. And we have been given an equation there. So since we have been given an equation, we can use this same equation because we know that y is 0 in both instances. So what we are simply saying is where there is y, we put 0. So we are going to have now an equation 2 plus x minus x squared is equals to 0. So the fact that the highest power is 2 there, we know that this is a quadratic. So we are going to say a is equals to, okay, that is -1 there. Then our b is equals to 1. Then our c is equals to 2. So we find our product, which is a times c. So our product will be -2. Then we are going to find our factors. Two factors such that when we add them, they will be equal to 1. But when we multiply, they will still give us back the -2. So what we are going to do here is very simple. We are going to check if you get -2, if you get 2 minus 1 here, you are going to find 1. So this one we can rewrite. So we are saying we have 2 and -1. So these are the factors, because when you say 2 minus 1, it will give us 1. But when you say 2 multiplied by -1, it will give us -2. Okay, we all have knowledge on these things. So we rewrite this one. It means these, they will replace this guy here. So instead, we're going to write 2 plus 2x minus x squared. Okay, so these two have replaced that one. Then we categorize these like that because it's factorization. So what is common in here is 2 open brackets. We remain with 1 plus x. Then the negative here, what is common there is x. Then here I'll remain with 1. Negative and negatives give me plus. So I remain with x there. Then this and this are the same, which is enough evidence that I'm doing the correct thing. So finally, the factorized equation now here will be 2 minus x, and I get one of these since they are the same, which will be x plus 1. So this is equal to 0. Then the next thing that you're going to do is you solve this one. So 2 minus x is equals to 0. So this one will be negative x is equals to 0 minus 2 because it goes there. So multiplied by a -1, it will be x is equals to, also here by a -1, x is equals to 2. So you have found your value there, x is equals to 2. Then you also solve this one, which is x plus 1 is equals to 0. So x will be equal to 0 minus 1. So x is equals to -1. Now, you have found two values of x. The other one is -1, the other one is 2, which makes sense. This side of the x-axis is positive, this side is negative. So definitely our e now here, it will be, because it's a negative side, it will be -1, 0. And this other one will be 2, 0. And you have found the coordinates. Okay, so the second question here, it says something that is very simple. Now, here we are trying to apply calculus. So something that is very simple here, they are saying find the maximum value of y. So to find the maximum value of y, we are going to use, because the maximum value of y is here, where it is turning. And we know that at the turning point, dy by dx is equals to 0. So we are simply going to say, okay, dy by dx is equals to 0, okay? Which is equals to, in this case now, so dy by dx is equals to 0. So the first thing that we are going to do now is we are going to differentiate this equation here. So dy by dx of this equation here, this is a constant, it will be 0, so we ignore it. This one is just x, so it will just be 1 minus 2x. That is dy by dx of this one. Then they are telling us dy by dx should be equal to 0 because it is turning. So now we have our equation there. So this one will be negative 2x is equals to 0. Then this crosses that side, it will be minus 1. So divided by minus 2, divided by minus 2. This and that goes, this and that goes. So our x is equals to half. Okay, so that is how you find the value. Now, before calculus was introduced into the syllabus, there was some Crooks method that we were using, but it works because there was no calculus in syllabus D. So what you can do is, because you know that between this one and this one, this graph is going to turn right at the line of symmetry. So you can easily say you add these two and this one here, and then you divide it by 2. So you find the average of these points. So 2 plus this one here, then divided by 2. I'm sure you will still find the same value. But maximum value y, which is here, we have found our x. So we'll substitute into the equation directly. Y is equals to 2 plus x minus x squared. So this one will be equal to, so 2 plus our x here, we know it's half, then minus, this is half squared, okay? So we solve this one, we are going to have, this is as good as 2 plus 1 over 2, so this is over 1, then plus, so squared, this is 1 over 4, because 1 squared is 1, then 2 squared is 4. So there we can sort it out, okay? We sort it out. Our marker seems to be failing due to gravity, okay? But it will work. So we have 4, then 1 into 4 is 4. So 4 times 2, this one is 8, plus 2 into 4 is 2, times 1 is 2, plus 4 into 4 is 1, times 1 is 1. So this one will be equal to 8 plus 2, that is 10, 10 plus 1, that is 11, so 11 over 4. And this one is equals to 2, remainder 3 over 4. And we have found our answer. And this is how we determine the value. Okay, so I think we'll end here for now. We'll do more practice on the sample question that appears in your paper 1 exam. So please revise on this and we'll do the other questions later on. Thank you.